So here I have an blank VISSIM. We will go to, well, let's go to Austin, where I'm currently located. So this is our beautiful city of Austin. I'll just hide the background and draw a simple intersection. So to draw an intersection, we can draw a directional link like this. And for visualization, I'll draw 3 lanes this time. So 3 lanes in each direction. So this is one link. 2000 feet is pretty long, so we don't need that long. Here we have this one link. To draw the opposite direction, VISSIM has this cool feature where you can right click and generate opposite direction. And it's gonna ask us number of lanes in opposite direction. For this one, let's call it 2. So this is opposite direction. I'm gonna move it a little bit for visualization purposes. Then in other direction as well. So let's call it 3 lanes. Please note that if north is upwards, this is our northbound, this is our eastbound. So we will use these terms pretty frequently, which are used in practice. So let's say 2 lanes, or I'll just keep it 3 so I can draw it a little bit faster. So this is the eastbound and this is the northbound. Let's draw the westbound leg. So this is the westbound leg, and same generate opposite directions. Generate opposite direction is very helpful when we have the curvature. So let's say we are drawing a link um, with a curvature on it, and many times if we want to draw the opposite direction, instead of starting to draw like this, what we can do is we can just generate opposite direction. uh, this is where is frequently used, so now it can generate the other direction of traffic. So I will so this is our northbound. um, what I will do is I'll give different color to the incoming lane and different color to the outgoing lane. So later here we are gonna declare this as 3 and generate opposite directions. Okay, so these are different legs of the intersection. Again, what I'm gonna do is I'm gonna give different colors to this legs, so we know the what are approach legs and what are exiting legs. So what we will do is go to base data display types. Here we'll declare one new or maybe 2 new. So let's call this approach leg. This is not what we typically do in practice, but just for the visualization purposes for this video, I'll call it outgoing leg. I'm going to give 2 different colors. So for the approach leg, I will leave the default color, which is what we use, and for the outgoing leg, I will choose another color. Let's say this one. Now, mm, for this outgoing leg, we will declare the display type as outgoing. Notice the change in color. This is just for visualization purposes. Also, it explains the concept of incoming leg and outgoing leg. So outgoing leg. Okay. Now what we will do is we'll draw the connectors. So through connector is on another screen. Click OK. Then through connectors. These through connectors. For through, I'll connect like this. This left hand connector. Usually left hands are single lane, but for simplicity, let's just draw it like this. or we can make it a single lane. Lane 1 to lane 1, lane 1 to lane 2. So I should use lane 3 to lane 2. Here also lane 3 to lane 2. Throughs are just throughs. Right turns are right turns. For simplicity, I'll just connect it like this. So I have a right turn here, I have a through here. Sorry, right turn will go from the right lane, then a left turn here. So the left turn will go from the left lane here. In past, this shifting of this visual shifting of these connectors were not allowed, so we used to keep track of which lane is 1, which lane is 2. But nowadays what we can do is we can just select any one, and we can visually change these connectors, so we don't need to keep track of those any nowadays. So we have right turn here, through here. We're gonna need a left turn here. Let's call it like this. So there is a left turn in this direction, we need a right turn. And here, so these are all the connectors which we are going to use. I'll pull this a little bit back so it looks a little bit nicer. Okay, so three outgoing from this northbound, 3 outgoing from this westbound, 3 outgoing from the southbound, and 3 outgoing from the eastbound. What we will do is we will select them all, right click, generate spline 6. So it's kind of look nice. So these are different lanes and connectors. This is a typical intersection. Now if we want to put the volumes in, we will create vehicle input. So some vehicles will enter from here, so we'll click here. Some vehicles will enter from here, we click here. Some vehicles will enter from here, click here. Some vehicles will enter from here. Now next we need is the routes. So vehicles which are entering from here will create a route decision, can either take a U-turn. We have not put the U-turn here, but uh, we'll skip the U-turn. So here they can take the left turn, or take the through, or take the right. So there are 3 routes starting from this decision point. So this pink is the decision point and this yellow is the route. Then from here we have this left turn, through, right. Then from here we have this left turn, through, and right. And then from here we have this left turn, through, and right as well. So we have 4 vehicle inputs. Again, the convention is this is northbound, not convention. So when the north arrow is up, so when the up is the north direction, this is northbound, this is southbound, this is eastbound, this is westbound. So in the northbound direction, we have 1 vehicle input, 1 decision point, which leads to 3 routes. Same with all other approaches. The blue colored are the receiving lanes. Connector can be any color. If we hit Control A on our keyboard, it's a node, it's a link connector system. So connector, they can be, for simplicity, we can probably assign another color to connector, or we can leave it as it is. So this is how we define the turning moment volume. Then let's switch back to Excel and see how we collect the turning moment counts, how does it look like, and then how we can input those here. So this is the same Excel we have worked on previous video. What we're gonna do is we're gonna create an intersection here, which is how it looks like in practice. So I'm gonna create a vertical line here by formatting, format cells, borders, and an horizontal line, format cells. This is how we typically draw the intersections. Each intersection has an ID. Um, we'll talk about the importance of ID later. So in the northbound direction, for the convention, this is our northbound quadrant, this is westbound, this is southbound, and this is eastbound. So we have, first we usually have U-turns, left turns, through, and right turns. The same in other direction, we have U-turn, next one is left turn, then we have through, then we have right turn, U-turn, left turn, through, right turn in the westbound direction. Usually we just copy paste the template so we don't have to actually type these things. I'm typing it for the um, video purposes. However, we can just simply copy this once this is set. U-turn, we're gonna use, we don't have U-turn, so we'll leave it alone. Left turn, let's call it 10. Through, let's call it 100. Right turn, let's call it 11. So this is the northbound volumes. Left turn in the westbound direction, let's say 20. Throughs, let's say 200. Right turn, let's say 22. Similarly, in the southbound direction, left turn, let's say 30, 300, and 33. In the eastbound direction, the left turn is call it 40, through 400, right turn 44. So let's say we have an intersection like this. We went in field and we collected the data, and the data looks something like this, for example. So if we want to transfer this data into VISSIM, let's see how we will do it manually, and then how we will do it using the VBA. So to manually transfer, first we need to know how many vehicles are going in. So this will be equal to sum of all these vehicles. So in northbound direction, for consistency, I will also include U-turn even though we don't have it. This is the number of vehicles going in is equal to sum of these is equal to sum of these numbers and is equal to sum of these numbers. So these are the number of vehicles going in. For last many years we give it a color green, so I'm gonna just give it a green color. We don't need to know number of vehicles going out. Those are mostly for the balancing purposes. Since we have only one intersection, we are just interested in number of vehicles going in. So if I want to code this manually, I will click on this vehicle input, and assuming there is only one time period, I will manually type it 121. Then for the uh, for the second vehicle input in this westbound direction, we have 242. In the southbound direction, we have 363. And in the eastbound direction, we have 484. So this is how I would manually input the vehicle input. Then for the static routes, For route number 1, we have the left turn, and I'm gonna drop these columns. We are not gonna use it right now. So the left turn here, we're gonna put 10, then throughs 100, and right turn 11. At some point we will discuss the concept of short routes versus long routes. In another direction, which is the westbound, the same thing. We will put 20 here, we will put 200 here, and 22 here. Same for the southbound direction. We will put 30 here, we will put 300 here, we will put 33 here. And in another direction, which is the eastbound, we'll put 40 here, 400 here, and 44 here. So this is how we would manually input these numbers. However, there is not only one relative flow, usually there are 12. So for one single intersections in practice, typically we have 12 different columns and we have to put different numbers in 12 of them just for the one intersection. So we can see how tedious this task is. We usually have EITs or interns do this task, and the thing about VISSIM is if you get one of them wrong, instead of let's say 100, somebody typed 200 or something wrong, then the entire VISSIM network assignment fails. So if some of the inputs or routes are wrong, then it reflects throughout the network. So that's one of the disadvantages, are that errors are not localized, errors are system wide. So if you make one mistake, usually the entire system uh, reflects that error. So we will see how we can simply um, transfer these numbers manually. So what I will do is I'll go ahead and delete what we have done. So I'll delete this to 0, and in the static routes I'll select them all at once, and I'm gonna change everything to 1. So I changed everything back to default, and we will see how we can do the same exercise with COM, and if we have 12 of them, how the COM interface can save us a lot of time for one single intersection. I'm going to save this in the same folder as the Excel file and call it 2 basics of vissim 2.inpx. Here we have this code from the previous video. I'm gonna drag this a little bit towards the left for consistency. The way we linked any intersection to VISSIM is by intersection IDs. Let's say we have hundreds of this intersection and we want to transfer hundreds of these volumes. We cannot write a code for each number. So the way we link it is we um, change the color of the ID. Let's call it yellow, and let's give it an ID. So usually we have like 1, 101, 1, 2, 3, 4, like whatever we use in data collection. So right now I'm gonna call it X, uh, where X, are intersection IDs. Usually we have this X as 1, 2, 3, 4, or 101, 102. Um, since we want this to be a numeric, I'm gonna call it intersection ID, let's say 101. So 101 in yellow color, let's say we have 50 different intersection like this. So one intersection is here, another one is here, another one is here in the system. Usually they are vertically aligned, but let's say we have a lot of intersections like this. So this is 102 and this is 103. And let's say we want to transfer all these volumes to VISSIM. So the way we automate this process is we first trace the ID, and then we look at all the numbers in certain pattern. So I'm gonna undo, and we're gonna just stick with one of the IDs, which is this one. So the way we are going to search is, first we are going to search for the ID. So I'm gonna search it here. For I is equal to 1 to, usually I use 500, I'm gonna use 500, even though it's gonna be slow. For j is equal to 1 to 500. You would be amazed on how much data we have in practice. So um, just to keep it practical, I'm gonna use 500. Next, the first thing we wanna check is the color and the font, the color of this cell and the font color of this cell. We can also change the font color. So let's change the font color to, yeah, this seems nice. So first we are going to look at this intersection ID. So the first thing we want to make sure is we are looking for a cell that's not blank and the number inside is numeric. So we are not looking for text. So the way to do that is if cells, before that, uh, actually we should have select the appropriate seed. So I'm gonna call it seeds seed 1. Even though it's not needed here, it's a good practice. Select. So I'm gonna select the seed 1 first. Let's say we have 12 different seeds with 12 different TMC. Then you will just select different seeds here and run the same piece of code. So here I'm selecting seed 1, and on seed 1 I'm checking each cell, um, 500 rows and 500 columns one by one. So if cells I dot j dot value. So first thing we wanna check is whether is numeric. So is numeric, and it should not be blank. So is numeric is not equal to true. Sorry, is numeric is equal to true. So we want the number to be numeric and we don't want the number to be blank. So is empty, is empty cells I comma j dot value. So first we are checking if the number is numeric is true and is empty is not equal to true. We can say is equal to false, but for some reason sometime it doesn't work. So we're gonna call it is not equal to true. Then we're gonna, if the number is numeric and the cell is not empty, then we're gonna close this. If for the next one we're gonna check the color. So if cells I comma j dot, first we're gonna check the font color, font dot color index. So right now we have like a dark red or brownish color. So color index I looked up online is 46, and the background color here, which is yellow, cells I comma j dot value is equal to, for yellow is 6. Then we're gonna call it and if, and we're gonna put most of our VISSIM code inside this. So we wanna select the seed, then we will look for the all the cells which are matching the index. So the way to search for index is it needs to be a numeric and it's not empty, and the background color is yellow and the font color is kind of dark red or brown. So this is our code. Here I should say J. Inside this, once we found this one, what we want to do is we want to transfer these ones, but we need to know uh, which vehicle input we are going to use. So to do that, we will go back to VISSIM and assign some name to it. So I have come up with a naming convention which I use. I give this vehicle input 101 underscore 1, calling it northbound. I will call this 101 underscore 2. So is the intersection ID underscore 1, intersection ID underscore 2, 101 underscore 3 is just a naming convention I have used. Many engineers use their own thing. Um, you are welcome to think more creative and come up with many other naming convention or ways to transfer. So this is the naming convention I'm gonna use, and I will switch back to VISSIM. So in VISSIM, when I'm creating these inputs, I usually give it a name. So when this input was created, I should call it 101 underscore 1. Um, this part can also be slightly automated, which is an advanced way of doing things is using these nodes. So we can draw a node like this, and many people have written several code to automate based on these node IDs. That will be pretty cool. So let's say 101. So this node ID, if you see, is 101, and it assigns these routes and this vehicle input by itself based on node ID. However, we're gonna see probably an example of that in future videos, but for now we're gonna manually assign it. But that's a pretty fast way of declaring the inputs and route names. So for this one, we're gonna call it 101 and switch to vehicle input. For the second one, we're gonna call it 101 underscore 2. For the third one, 101 underscore 3. And for the last one, 101 underscore 4. Since I know that I'm gonna use the same names in the routes, I'm gonna copy this one, and for this route, I'm gonna call it 101 underscore 1, 101 underscore 2. So I'm gonna just copy paste it from the input. If I can get it to paste. Okay. So this route is 101 underscore 1, 101 underscore 2. So this is a naming convention I have been using for more than 10 years. Uh, we can do it by node, but that's a little bit complex code to write. But that definitely saves time and manual errors. So right now we're gonna use this name, and we're gonna read this name, and based on these names we are going to assign the volumes. So going back to the Excel, so this VISSIM is basics of VISSIM underscore 2. So going back to Excel, here I will change the input name. So what we're gonna do is we are first looking to assign the vehicle input. So I will cut this part, and we will work with vehicle inputs first. So for each vehicle input, first we want to do is we want to check the names. If we are going to declare another variable which breaks the string, so we're gonna call it parts input as variant, and we're gonna use parts route as variant. So we're gonna use these two to break up the name into different pieces. So uh, first we're gonna read the names. So if first we're gonna check if it has an underscore, because I usually use underscore for intersections, and all the other inputs does not have underscore. So for my particular piece of code, the underscore defines an intersection. So first we want to check whether there is an underscore. So if INSTR, so we're gonna call it vehicle in dot attribute value. We are looking for name. So if within the name there is an underscore, then we have found one intersection which we are looking to process. So and if so if vehicle input dot attribute value, so probably make this capital. So if vehicle input attribute value name has underscore, then we know that it's an intersection. What we want to do is first we want to break the name. So parts input is equal to split. We will copy this instead of typing it one more time. Split the name. Then we're gonna check whether the first part of the name, um, which is the ID, matches the ID in the Excel. So the vehicle input name, first part of name, we can get it by parts input 0. This is the first part of the name from VISSIM. If first part of name from VISSIM is equal to cells I comma j dot value is equal to our node ID, then we want to proceed further. You're gonna call it end if. Then what we want to do is we want to assign vehicle inputs. So uh, first we wanna get the directions as well. So here we are matching the IDs coming from VISSIM to ID coming from Excel. Once we match the ID, then we're gonna look at the directions. So one more if parts input 1. So if part input 1, which is the second part of the name, so I'll put the name for the visualization purposes. So we are looking at, let's say, 101 underscore 2. So if we want to break this one, our vehicle in attribute value will be 101 underscore 2. Then uh, once we split it, it will be broken into two pieces, 101, which is gonna match the ID, and this, which is gonna match the direction. So if part 1 is equal to 1, which means we are looking for northbound, then and if part 1 is equal to 1, then what we want to do is we want to put uh, vehicle input dot attribute value. We actually have it here, assuming that there is only one time interval, so we're gonna paste it here. So vehicle input dot attribute value volume 1 is equal to, instead of a constant number, we're gonna read it from Excel. So cells, notice that if this is row I, then we are moving 1 2 3 4 5 6 down, so I plus 6, and one column in front, dot value. So dot I plus 6, I and j is this particular cell in Excel. I plus 6 is this cell, and I plus 6 and j plus 1 is this cell. So if my directions is 1, which is northbound, then assign this value to the attribute vehicle input. Similarly, we can copy paste this 4 times for 4 of the directions. So we have northbound, direction number 2 is westbound, direction number 3 is southbound, direction number 4 is eastbound. Um, we're gonna change this one to 2, this one to 3, this one to 4. And to get the westbound volumes, we need I minus 1. So this one will change to I minus 1 because we are going one row back, and j 1 2 3 4 5 1 2 3 4 5 6. For the southbound direction, we are going I minus 1 2 3 4 5 6 minus 6, and j minus 1 because we are going one column back. For this one, we are going one row above, so I plus 1, and j minus x, and that should input our volume. So I'll run the code before we go to routing, and this is how the input code will look like. The same thing we will do, we will switch this, push this input inside and write a kind of a long list of this code. The good thing is, if you are done writing this code one time in your entire career, you just have to play with this, fill this one up and prepare the VISSIM. You don't have to rewrite it again, and the code would transfer all the volumes by itself. So even though it may take some effort to write the code, let's say 30 minutes to 1 hour to 2 hours, once you write it, you're gonna save. It's manually inputting the volumes in practice. Let's say for 10 intersection, typically takes manually inputting, checking the errors. This can take between 1 to 2 weeks, and the same work can be done within few hours using this. So we are going to run this one. Hopefully there are typos. Usually when we are writing code, there are typos, so it's a wishful thinking. Um, Looking at the code, I just realized that I should use the color here. So cell I dot I comma j dot value, we are looking at interior dot color index. So we are looking for interior color index. We're gonna run this code. We're gonna stop it here. So it's gonna create the VISSIM network and load this particular file, and I'm gonna split screen next. So I'm going to run this. It's gonna take some time, and I will put the new VISSIM file in the middle. So I put the code on the left hand side now. This is the traffic volume, the same traffic volume, and this is the vehicle input that has opened up. So we'll click on vehicle input. We'll see how it currently looks like, and if I can see, so currently in the vehicle input we have these names. Actually I found one error, 101 underscore 2. uh, the volumes are 0, and we are hoping that these zeros will be replaced with the numbers from Excel. So 121, 242, and so forth. Usually we don't need this. Uh, we don't. We are not actually gonna use this. So I'm gonna delete it uh, to show that we don't actually need those things. It's mostly for a demonstration purposes. So we're gonna read this name. We're gonna split this name into two pieces. We're gonna match the first part with the Excel ID. We're gonna match the second part with the directions. One is always the convention I use is 1 is always northbound, 2 is always westbound, 3 is always southbound, 4 is always eastbound, and that's how I build my code on. But we can build, many engineers can build their own way of declaring the directions. So here we're gonna hit F8. Seed 1 is selected, so we are working on this seed. It's gonna go through. It will be a while before it can find an index, so I'm gonna put a break here and let it run through. So right now is under row 8 and column 8. So row 8 is this one, column 8 is this one, so it's under this cell. So it has found that this is a cell we are looking for with correct color and correct font, and is a numeric and is not empty. Now for each vehicle input, first we're gonna look at the name attribute, then we're gonna split the name, and we're gonna so if we hover over here, we can actually see the name is pulling from VISSIM. So within the VISSIM, actually I should have put an underscore how to split it. So we are looking to split the name based on underscore. So excuse me for a second. I'm gonna rerun this, and since I missed this part, I'm gonna rerun it and reopen it. So we are looking to split the name based on underscore and then read the first and second part. So when we hover over a variable, it tells us what the variable is, even though it's coming from VISSIM. So I just reran the VISSIM, and this is the new VISSIM that has opened because we missed this underscore. So we are gonna continue. Here, if I hover over here, now notice that the first part is 101, which is splitting the first name, and the second part would be 1. That's how it will know that is a northbound. So we're gonna go continue, name underscore, then if first part is equal to this value 101, actually I forgot to save, so 101 should have saved. So I was just looking at this. It seems like it's breaking it up as an string because this is a string. So what we might want to do is we put a cint, which is going to change this integer, which is going to change this uh, this particular string into integer. So first part is coming so this cell value, this number is 101, but it's reading it as a string from the VISSIM, so that's why it's not matching. So what we are going to do is we are calling it cint, and then we're gonna add watch to it, click OK, and now it's coming as an integer which is going to match the VISSIM. So let me run it one more time, or we can just continue to see because we still have one more left. So we are I think we are currently at 101 underscore 3. um, to avoid the confusion, I'm just gonna run it and stop it. So I have rerun it. There are two mistakes we have fixed so far. So there was this underscore missing, and we have declared this int. In past I didn't have to declare it, but sometime we have to use it depending on which VBA version we are using. Sometime they are is picky, so uh, sometime we don't have to declare it. Sometime changing this string into int. If it's an integer, it still changes into an integer. So we're gonna continue. So first we are looking at this vehicle attribute, and right now the parts are empty. So here we can see the first part is reading as 101, second part is reading as 1, which is we are looking at this particular vehicle input, uh, which actually corresponds to this one. So when we select it, it also selects this one. So this is deselecting, this is selecting. So deselecting and selecting, and go to F8. And if we are looking for northbound, yes, we are looking for northbound, it's gonna assign 121, which is exactly what we were looking to do. Then for the other direction, it's gonna skip it. Then for the next one, we are looking at this one, which is westbound. It's gonna assign 242, which is what we were looking, and I'm gonna run it through for the other two. So I'll just press this button and it's gonna run it for other two. So 363, 484. Let's imagine that there are 12 different seats and we have let's say 20 intersections. So number of data input points will be, so if we have 20 intersections and each intersection needs um, 4 input like this, and then this is for one time interval, and usually we have 12 time interval. 12 time interval corresponds to uh, 3 hours. I think at bare minimum we usually have four time intervals, which is only peak hour analysis. Then we have AM and PM, so which is 8. So I'm gonna call it 8. So let's say we have 20 intersections. Then each intersection has 4 directions and 8 15-minute volumes. one for AM and PM. This is kind of a minimum what we were looking to input the data. So 20, uh, this is 80 and 640. So there are 640 data input points just for the input, uh, which we kind of automated. So for a typical intersection, a typical project with 20 intersection, we would have to type these 640 numbers. Another thing to note is the new VISSIM is very user friendly. It can be copy pasted. So instead of using the COM, if we are just using the vehicle input, if we somehow arrange it in a certain way, so let's say using some script or something, we are able to arrange this as 242, 363, 484. If we are able to arrange it like this for time interval 1, and let's say it's the same number for other one, so um, for other ones I'm gonna use a random number multiplied by 1000, random function multiplied by 1000. So let's say these are the different inputs for different time intervals, and let's assume they are actually integers. So number of, so something like this. So in time interval 1, this is our green, time interval 2, this is our green. If we can arrange it like this, we can simply copy paste it in VISSIM. We don't actually need the COM. Before 5 point, before version 6, I think we had to manually input them one by one by clicking this and then clicking this. But nowadays we can just simply copy paste. For example, if I delete all this and if I just copy this from Excel and paste it, it is gonna come within the VISSIM very nicely. So we don't actually need the COM if we are just looking for vehicle input, but we can do many great things with this concept, which we will look in further videos. So overall, this is how we reduce the manual time to transfer um, Excel data into VISSIM, and it can, by doing it by hand compared to doing it by hand, it can save us 1 to 2 weeks of time, and it's a repetitive, so the code does not usually make mistake. Well, usually, because sometimes things are weird. Uh, so what we will do is we will not write the code for routing. The same exact same thing applies for routing. We will go and check the route name, then we'll split them into pieces and then assign it. So what I will do is we will provide the actual code which can read the. We will provide an Excel with many seats, let's say for turning moment count, which can read the counts from here, which can read the freeways, and which can read these counts as well as which can be used for freeways as well. So, and we will put some instructions. So let's say we have a freeway entry and exit, we can manually declare them on another seat and transfer it to COM. So we will provide all those resources directly, and we don't need to go through the code for those. We will provide the code in a PDF format. However, we don't need to go through each of them. They are just an expanded version of this. So if you copy paste this over 10 times, and so it's just an expanded version of this basic code we have discussed. So yeah, I'm hoping this will help everyone do things a little bit faster and a logical way. Uh, this is what we do on most of the project to do things faster. Again, is we can still use the copy paste feature within VISSIM, but the importance of COM is we can do many more things with it. So we will look some of the more advanced and very complex scenarios in the next video. And those are how to read back the link volumes. What does it even mean to read back? Those are very complex for much advanced users. You need to have much deeper understanding of what volume means from the mathematics perspective. So we'll discuss all those very deep concepts in the next videos. So thank you so much for joining in, and please check out the next videos.